Alright, so welcome to section 6.1. Today we're going to talk about rational exponents. So, the list on the left is probably a list we've seen before, but if you're talking about perfect squares, that's like 1 squared, which is 1 times 1, which is 1. 2 squared, 2 times 2, 4. 3 squared is 9, and then 16, and 25. And this list will go all the way down to 12 squared. And yes, of course, it keeps going, but these are some of the most common values that we would see if we were listing out perfect squares. On the other side, you take those perfect squares, you take the square root, you should be getting a rational number. So the square root of 1 is 1. The square root of 4 is 2, and so forth. But what we're looking at today that will be just a little bit different is how do we show this using rational exponents instead of with the radicand. So you can think about the root that you're taking as the denominator when you write your rational exponents. So this is the square root. That means we're trying to find what number multiplied by itself 2 times will make, for example, 9. And that would be 3. So because it's 2 times, we need to multiply 3 2 times. 2 is going to go in the denominator of our exponent. So the square root of 1 is 1 to the 1/2. And then the square root of 4 is 4 to the 1/2. And the square root of 9 is the same as 9 to the 1/2. And we keep going. It's always to the 1/2 if you're taking the square root. And you can write the values again. And that completes our first table. Now let's look at this in terms of cubes and cubic roots. If you have 1 cubed, that's the same as 1 times 1 times 1, which is 1. And then 2 times 2 times 2, that makes 8. 3 times 3 times 3, we get 27. 4 times 4 times 4, 64. 5 times 5 times 5, 125. And then the last value, we're taking 12 times 12 times 12, and we should be getting a pretty big number, 1,728. So if you want to find the cube root of any of these numbers, just like when you use the square root, I don't know if you caught what I was putting inside or in front of the radicand, but that's how you specify the root that you want to find of a given value. So if we want to find the cube root or the cubic root of 1, we would still draw the radicand, still write the number underneath it, but this time the root that we want to find is the cube root. And for 8, same thing. Draw the radicand, but this time it's the cube root, not the square root, so you write a 3. It kind of looks like an elbow with a hand that's being held out if you look at the radicand. Like, here's the elbow, here's the hand. You want to write the number directly over the hand. So 3, the radicand, and then 27. And then again, same here, and we would call this again cube root or cubic root of 125, and then the cubic root of 1,728. what we had with the last slide. It was the square root. So what number did we have to multiply 2 times to make our value? Same idea, it's just now we're multiplying 3 times. And on the last slide, the 2 is what went to the denominator. Now the 3 is what's going to the denominator. And for now, all we're writing is 1 over it. So the cube root of 1 is the same as 1 to the 1/3 power. And the cube root of 8 is the same as 8 to the 1/3 power. And then the cube root of 27 is the same as 27 to the 1/3. 64 to the 1/3 is the same as cube root of 64. All of these, instead of cube root, we can write to the 1/3 power. And you can do this with any power, like say 4. And for this one, I think it's easier to pull up your calculator because 4th powers are not quite as familiar. We can probably get some of those smaller ones, like 1 to the 4th power is the same as, I can do some side notes here. 1 times 1 times 1 times 1. That one's still just 1. You do 2 to the 4th power, that's the same thing as 2 times 2 times 2 times 2. We get 16, and you can see how quickly these values are increasing. Next would be 3 times 3 times 3 times 3, which is 81. And then we have 4 times 4 times 4 times 4. Then you have 5 to the 4th power, which is 5 times 5 times 5 times 5, which is 625. And here's where I definitely say pull up the calculator. You can just type in 12, and then again your exponent key is right here, just above the division key. The power we want is 4, and then you can hit enter. 20,736. So if you take the cube root, or sorry, not cube root, the 4th root of all of these numbers, again, you have almost like a hand for a bent arm. Write the root that you want right above the hand. So it's 4th root 1 equals 1. 4th root 16 equals 2, and so forth. And we can just fill in the rest of our table. After that, we will talk about the exponent, but it's not going to be any different from what we've looked at so far. I'm almost done. This time 4 is the root we're taking, so the fraction, the denominator that we're going to write in the fraction exponent is 4. So the 4th root of 1 is the same as 1 to the 1/4 power. And for 16 to the 1/4, that's the same root as 4th root 16, and so forth. Everything that you're taking the 4th root of can be rewritten as to the 1/4 power. right. So let's also, a few things to remember. You cannot work with negatives when you have even roots. Just like we can't take the square root of negative 64. That will give us imaginary numbers. So we can't deal with those when we're dealing with even roots. However, we can have negative numbers when you have odd roots. If you are solving equations with an even number of roots, you'll have two answers. And then you will have one answer when you are solving equations with an odd root. So, negative exponents are a little bit different than negative bases. So with negative exponents, you can turn them positive by changing which side of the fraction bar they're on. And there's a saying that goes with it. It's cross the line and change the sign. So x to the negative 1/2. You can think about that as x to the negative 1/2 over 1. So if you cross the line, you can change the sign of the fraction. So that becomes 1 over x squared. For this second example, it doesn't look all that friendly to try to change. But if you go back to that table that we just filled out, we already looked at what the fourth root of 16 is, and that's 2. So you can simplify this by calling it 2 to the negative 3rd power. And now it's the exact same type of question that we just had. Cross the line and change the sign. And remember, 2 to the 3rd is the same thing as 2 times 2 times 2, so we get 1/8 for this example. And then for this last example, we can write this as 27 to the negative 1/3 over the number 1. Again, you want to cross the line and change the sign. And remember, we said if something is raised to the 1/3 power, that's the same as the cube root. So this is the same as 1 over the cube root of 27, which is 3. All right. In the next video, we're going to go over some examples. Solving is a great topic, which we will look at a later time. But in the next video, we're just going to go over a few quick examples for how you can use exponents in an equation, or in a problem, I should say.